You want to do the quadratic formula or completing the square first?
Complete the square.
Okay, you got it. Completing the square, first thing we got to do, we got to make sure, or we don't have to, but one method is to get your variable terms on one side of the equation and your constants on the other. So we got to make sure this positive 5 gets moved over to the other side. All right? So we'll subtract 5 from here, we'll subtract 5 from here. So 3x squared minus 12x. Because I got a blank space, baby. And now I'll write your name. I'm not going to write your name here. Right? But something will go there eventually. See? I told you. Taylor Swift has all the answers. All right? To everything. So, once we have our variable terms separated from our constant, we are factoring away the coefficient of the squared term. Not the greatest common factor. It's coincidental right now that 3 is a factor of 12. I'm trying to make it easier in the early going here. Okay? But we are factoring out a 3. If this was a 5 and that was a 12, I would factor out a 5. This would become a fraction like it did before, and it was horrible, and it will be horrible again at times. But for right now, we're factoring the 3 away from x squared. We're factoring the 3 away from here. I am not factoring the 3 away from the other side. We're only factoring this left side. Okay? Now I haven't introduced any new terms. I've just rewritten a couple of times now what this expression, what this equation was saying. Okay? So after we have just x squared and this x term or non-squared term, we take half of this number, this negative 4. Half of negative 4 is negative 2, and negative 2 squared is positive 4. So I add 4. Or do I? No, I don't add 4. I write plus 4, but I'm not adding 4. I am adding 12, right? It's the 3 outside these parentheses. That's where the parentheses are important in this process. When I'm adding 4 here, I'm actually adding 12 because it's being multiplied by 3. So to maintain the balance of the equation, I have to add 12 on the other side. Now when I go to write this, sorry, went too far there. Now when I go to write this, I'm going to write this in its factored form. Right? What two numbers add to be negative 4, but multiply to be positive 4? Negative 2 and negative 2. And when you get to this point, if you're in the process of completing the square and you get to this point, it's the same number. That's the whole idea here, guys. It's the same number. When I say, what do you multiply to get positive 4 and add to be negative 4? It's like when I set up here, what do you add to get positive 2 and multiply to be positive 1? It's always the same number twice. So this is x minus 2 inside the binomial now. Okay? Remember, it's whatever this number is, then when I divided this by 2, but before I square it, let's say that again, are you listening? When I divide this by 2, whatever that number is, that's what I write in the binomial. I have to square it to get this number. But when I go to write the binomial, it's whatever this was when I divided it by 2 before I squared it that I write inside here. That's equal to 14. Now let's keep going. Let's solve this. It's going to get messy, but we're going to do it. Okay? Because what else we got to do? So, now that I have a squared binomial for x, this is my x term right here. I want to get that by itself. I can divide this entire expression by 3, which means I have to divide this by 3. I'm in a solving mode now. So I have x minus 2 squared equals 14 over 3. We don't want this squared. We want x. We don't want it squared. Now that it's the binomial that's squared, I can take the square root of the entire thing. The entire thing. The left side and the right side. Take the square root of both sides. So I have x minus 2 equals a positive and a negative. Now let's go through our radical review real quick. I'm taking the square root of a fraction. If you take the square root of a fraction, you can take the square root of the top and the bottom separately. So this is the square root of 14 over the square root of 3. And I do that so that I can practice another radical skill that we learned. We need to rationalize the denominator. Remember, we're going to pre-calc honors here, so up your game, right? So if I want to rationalize the denominator, I haven't even talked about what I'm going to do over here yet, because I got to simplify what I've got on this side. I don't want to add 2 to this. Let's make it a little bit easier to look at. Multiply by radical 3 on the denominator and on the top. So I get plus or minus. Can I multiply radicals that are different? Yes, I can. So on the top, I get the square root of 42, and on the bottom, I get 3. Get out of here, you. You're next. It's horrible looking, I get it, but this is the process. And then lastly, I'll add 2 to this. So I'm going to add 2. And I'm going to add 2. It depends on how terribly horrible you want to get with this. Quite honestly, I'm okay with that as an answer. But do you want to take it one step further? Everybody go like this?
Yes.
Yes, good answer. Good answer. You do want to take it one step further. Watch now. Remember, we're honor students in here. We're honor students. So we're going to do this. It's going to get crazy. I'm adding wrinkles to your brain right now, right? The 2 becomes a 6 over 3. Why?
6 over 3 is 2.
Because 6 over 3 is 2, and this is over 3. So now I actually want to write them together. Okay. Now wait for it. It's going to get even worse. You ready? You all watching? Boom. You want an honors level answer? That's an honors level answer. That's taking it to the next level. Commutative property of addition. I have it written like this, but I can write it like that. I can switch it around. That's an honors level question right there, yeah.
Is it a 42?
What did I say? Oh, 43. That's an honors level question with the mistake. This is an honors level question with the mistake corrected. There you go.